Hey, welcome, folks. This is our Design 301 lecture highlights. And welcome in, Stephen. Welcome, Anna. I've just turned the recording on. And this is our 301 lecture highlights section. And what I thought I would do, unless you have some specific questions, is show you two different types of operations that are really, really strong in Inventor. They're also strong in Fusion, but Inventor, they're just really cool. So I'm going to go, if you don't mind, to do something called a flat plate layout. So I'm going to come here to New, and I'm going to make something out of sheet metal. And they actually have a specialized set of tools for us to make something out of sheet metal. And you can see down here why that's kind of useful. It's a drawing system based around a method of manufacturing. And that's what Dynascape is. It's a drawing method based around a method of planting and hardscaping and working. So we can make sheet metal, we can do weldments, we can do standard parts. Here we'll do a sheet metal item. And I'm just going to make a box just because it's fun and easy to make a box. And it'll come up in just a moment. So I'm in Inventor. And the way Inventor works is much like AutoCAD, you start with a flat sketch and then you give it shape. So I'm going to start with my flat sketch and I'm just going to make a box here. This is another thing it does. Look at all these ways that you can make different shapes. There's that slot that you just did. Here's what you've always been looking for, Stephen. Center rectangle. So let me say it's a 6x6. And I'm not going to go into parameters and all that kind of stuff. But there it is. And now I'm going to do what's called making that a face. And so it's a face of the sheet metal object. There it is. And I'm using the defaults, which set that at 0.12. Here's the defaults. Okay, I think it's default sheet metal, generic, all that kind of stuff. So there it is. Now, to make a box, I know that I need a piece sticking up here, and that's called a flange. So I'll stick a flange on this top corner, and I'll make the height of the box 3. Isn't that cool? It actually bent it. It knows all about how to bend metal, and it bent it appropriately. So I'm going to make those ones all the same. And this last one is going to be just a little bit different. It's going to allow some air to come in. There. And isn't that cool? It even shows me the little gaps that I'm going to have to weld. I'm going to have to, well, maybe I won't have to weld them. It depends on what I'm going to do with this. Maybe I'll weld it or not. But it even shows me how I have to cut this area out so that it'll actually bend. It's so cool. It knows all that stuff. And now, just because this is going to be a box, it's going to cover something, and maybe some wires are going to come out or something like that. I'm going to put some little 1-inch flanges on these two outside edges. And isn't that the coolest thing? So just lickety split, I've been able to do that. And look, it even kept it level for me. It's figuring out all of my bends and everything to keep it all level and nice. Now, I think I probably want some holes in here. So I'm going to find a midline. And I'm going to put some holes in, but I'm going to do it in such a way. Well, there's two ways that I can do this. One, I can drill them in later on. I think what I'm going to do right now is just put a point in there, and then I'll come up. Let me just do this. Let me put another point in here. Maybe 1.5. But I need the dimension between those two things and actually make it 1.5. Isn't that cool? I got close, but then I made it right. Okay, and so let me do another one then. I'll do another point. Right there. And I'll put a dimension on that one also. And by putting in these dimensions, it allows me to type it in exactly what I want it to be. Now, if I make a line here just to make my life simple, and it doesn't look like I made it straight. Let me make sure I got it straight. I'm going to make it straight. And then, of course, I can do all the things I can normally do, like mirror about that line. And now I've got them over there too. So that's kind of cool. That's a part with a whole bunch of stuff added to it. Now, what's really fun is I can put in a hole, and it found all those, and I can just type in what size I want it to be. I'll make it for like a number 10 screw, which is 0.19 diameter. So usually it would be a 0.21 diameter hole. And I can do tolerances and all sorts of stuff to it. But I'm just going to put it in as a hole there. Now, since I called it a hole, later on, I can either identify that a machine tool will drill it, or I can just leave it as part of the geometry. So there, I got a box. And I can decide what to do with that box. I can seal it up for welding. I can just do like one little tack weld. But look, that's pretty stiff. If you've ever done any of this kind of stuff before, that's a heck of strong box, being a 0.12 thick. And I can change that if I want. I can not use the default, but I'm just going to do that. Here's the cool thing. If I say, here's a side, right there, that one right there is my flat A side, I can do what's called a flat plate layout, and it tells me exactly what to cut out and what to fold and where to drill or laser cut to make my part. Is that the coolest thing you've ever seen? I love it. And I can just go back to here.
Are there presets for wood? I know you started with one that was already in there for metal.
Well, you can't bend wood.
I see.
So with wood, you would do this and you would put cuts along here and you would change this preset width so that you know, if you know that you're gonna, lay the inside edge along here.
Right, but I mean, like, when you first started the drawing, you clicked on something that told it was metal, but I
Right.
didn't see an option for, working on stuff that was already pre-done wood stuff.
Yeah, so it's got to be something you can bend.
Okay.
I mean, here is wood, but it's not gonna. It's not. I mean, if you're bending, I mean, you can bend wood, but not really. So these ones don't really work that well.
Okay.
But you could do all these steels, stainless steels. You can do like polypropylene and PET, polycarbonate. I know you can bend that. I've done that before. So it sort of gives you this whole material list, but you got to sort of apply it in a way that you know how these things are happening. Like, what are the bend radiuses and what are you going to unfold and how are you going to set these thicknesses? So it really is for bendable stuff. Here's bend order. So you're going to bend that first, then bend that, and finally bend that. So that's really cool. And then, of course, I'll go back to my folded part. I can stay here and I can make a drawing view. Oh, I know. I do have to come back up here. I can make my drawing view. And I'll tell you, that is so fast compared to any other thing that you can sheet metal box. And we actually did this and did this process for the students that were putting something up into NASA. So let me go to a top view there. And probably that one should probably be a section, just for fun. Let me show you. I can make a section view of this. So it kind of shows, now I can point at these radii really easily to call them out. I've got the hole shown so I can dimension the holes. Although I've got them over here too. And then I'll just project this one over to here. There. And if I want to make a new sheet here, I can, when I put in my base view, I can actually have it show me the flat plate layout. So I have what the folded information is, and I've got this. And there's lots of cool ways I can do ordinates, which are really, really common. It makes a table of dimensions from different parts. So like ordinate set here, I'll use that as my 0 ordinate.
That would be for setting like the CNC cutter or the laser or something.
Yep. And so now you've got all your distances, right, to your bend lines. And because that's the thing, unless your laser is set on a light to be able to put in these lines, which many of them can do, by the way. So you don't really need to dimension this part because it's just going to go to your laser cutter, right? The only thing you actually need to dimension is what you want somebody to inspect or operate with later on. So I probably need this one, this one, this one, this one, and this one. There we go. And so that's just it's really cool, and it's a really quick way. And I didn't put this at the right spot, but that's okay. It really should have been out here. I thought I had set it out there, but I guess I didn't. I'm not sure I can move it, but I could have picked a better ordinate. And then the last thing you need to do is put the hole in. And it's the same thing, right? You put the 6 times right up front. But see how it does all this automatically for you? And you can do all sorts of, if there's, counterbores and countersinks and a quantity note, I don't see that done too much. I usually see just a thing like that. Maybe it would put the, you know what? Let's just try that out. Look at that. It counts them up for me because I called them holes. So it counts up all my holes. I didn't know it did that. So that's it. Now I got it. Now, if I want to, I can also bend notes. This puts the bend notes on it. And I think somewhere it gives me the bend order also. Let me see. No, I have to go look somewhere else for my order. There we go. I mean, that fast. That took me 15 minutes. I have a box designed. And not only do I have a box designed, I have almost an infinite number of boxes designed because I can go and look at these parameters and change different dimensions very quickly and easily. So I can set those up in Excel. So there we go. That's how sheet metal works. Now, let's just see. Let's say I wanted this sitting here and it's a protective cover for something of interest. And I want somebody to be able to stand on top of this or kick it or do something like that. So this is where we get into those environments again. And I can do a stress analysis. And I can do, I guess I've only got static analysis in here right now. In Fusion, I can do more types. So I can assign my material. And it's generic. So let's say I'm going to make this out of a, steels are pretty easy to bend. So I'll use a mild steel because that's easy to bend. And I have to say where it's going to get supported. That's what this fixed area is. And it's probably going to be sitting on something right there. And then I can either put a force on here or a pressure or both. I can do even more than that. So let's say I want somebody to jump on this that weighs 200 pounds. And they're just going to stand on it. 200 pounds, just standing on it. And let's just see what it'll do. So it doesn't really have much here in my stresses. 11,000 pounds per square inch. So now let's look at my safety factor. At the worst case, it's got a safety factor of 2.73. So a 400-pound person could stand on it. And let's see how much it's going to bend. 3/1000ths of an inch. So that 1/8 inch material is pretty darn strong. I now have a couple of options. I can save a little money, maybe, and make it out of 0.09. Or I can make it look groovy and put some holes in it. Maybe it needs to be able to vent heat. So I'll put some holes in here and see what happens. All sorts of things that I can try.
Why is it buckling on that back flange?
Right there. Well, first of all, it's when you look at its displacement factor, it's huge because that amount of motion is 3/1000ths of an inch.
I see.
Okay. But you can imagine as this pushes down, something's going to try to spread. These are bolted in place, so it can't spread here. So it's got to spread on these edges. But the zoom factor is humongous on this, right?
Mm-hmm.
Just so that you can see where it's going to go. And so if that wasn't acceptable to you for some reason, you would put a flange on there too and bolt it down. Or you go, oh, that's going to scrape and hit something. I'll make that, some tiny bit shorter or something like that. So it's really not deforming as much as you think it is from here. It's showing you a wildly magnified version of it.
Right. So if you've looked at your analysis now, you see that back piece bent out a little bit. Can you then add a weld joint on the corners to keep that from bending and then rerun it and see what it does? Or do you have to?
You can, but then you have to go into the weldment thing.
Okay.
So there's one extra step that you need to do. So now the easiest way to do that is you can fix one surface to another surface. So that would be one way to do it, right? You can fix the surfaces together. But in general, I mean, that number is so small, nobody would ever
right.
think about having a problem with that. Especially, 200 pounds sitting on top of this. So there's things you can do here. You can also, if I can remember, so I'm going to finish the analysis. I can use my shape generator on this to, let me see if I can do this now. Shape generator. Oh, I have to put my loads in for my shape generator. So now I have to do the same thing on my shape generator. And we'll see if I can get this to work, because this is the coolest thing. So this is going to tell you where you can remove material without really causing a problem. And it'll take a little while. It might take a minute or two. But this is really fun. And Fusion incorporates this shape generator to the hugest extent. You can even tell it to do it for 5 different materials with 4 different machining versions with all sorts of different operations, different load structures, and it'll give you an analysis of a set of shapes that you can then choose from. So hopefully this doesn't take too much longer, because you're going to find it's really kind of wild. It's going to show you areas where you just don't need material. And you can see up there that there are areas where you can tell it, leave this spot alone. You can say, make this part symmetrical to this part, because it just starts applying loads and scraping stuff away, and you can get some really weird shapes in this. So that's going to sit there. I guess I've got it cranking hard. This shouldn't be too hard of a thing for it to do. We'll all have fun watching this happen. I should have run this already, but I didn't even think about it. So while this one's running, I'm going to go ahead and do another new one. This time, I'm going to do a standard part, and then I'm going to make it into a weldment, just to show you another cool thing that you can do. So, and this is making a sort of a large frame weldment. So I'll make my frame, and my shape generator is still running. There we go. It's over there. And so I'm going to make a frame like this, and I'll make it out of a rectangle, and I'm going to make it big. I'm going to make it 8 feet wide, which is 96 inches by 96 tall. And then I'm gonna make a new plane. And I'm going to offset that also 96 inches. And I think that I can copy this sketch and that didn't work out right. Go back. Start a new sketch on here and paste. It's going to allow me to do that. Well, I'll just put a new one on there. I know I can copy and paste these things too. 96 by 96. And then I'll make another new plane just for fun. This is the hard part of this, is I'm always playing with, where are you drawing? And I'm going to move it up 96. And I'm going to draw on that plane. And I'll start about at minus 24. Oops. Come down to here. There's 100, so 144. And I'm going to copy that. And this will just show you sort of and I'll put a dimension between those, and that way I can set the distance. Oh, except it went the wrong way. Hate it when it does that. Here we go. Okay, so now I got this cool thing, and I'm going to do something that I'm going to hide. I'm going to hide these dimensions because I don't need them anymore. Oh, hid the wrong thing. Dimension visibility, and dimension. Okay, so now I've got a thing, and it's called my frame. So I'll save that. And you know what? I'm going to hide these work planes too. They're still there. I've just sort of hidden their visibility. Let's go back and see if our box is done. Okay, so where did it go? Did it, when I got out of it, I hope it didn't stop it.
You don't have shape generator highlighted, do you?
Oh, there it is. Let's see. Shape generator. Da, da, da. No, that should when I come down and look at these, those are all those constraints. Da, da, da. It should give me my results here, but it didn't. So if I did something wrong, it might have been when I jumped out of it. I'll come back and try that again at another time because I want to show you this part too. Okay, so there we go. I've got these two cool things. Now, when I make my weldment, I have to assemble it. I have to go place some parts, and I'll find it. There it is. Now here's the cool thing. When I go into design, it lets me pick different stuff. Yes. And this is going to be structural weldment. And I can pick what I'm going to make it out of. So I'll make it out of square tubing. And 2 by 2 by 1/8, just mild steel. And so then I can put it on there, and not only that, I can sort of decide where it's going to go. So let's do that again. I'm going to put it onto there. And I'll set it to the inside. And I'll put this one on. And I'll set it to the inside. Actually, let me put it inside corner. Just for fun. And I'm just doing that so I can show you. Ah, darn it. I hate it when I do that. I always hit escape instead of, there we go. There we go. I got to click OK. It's got to make those parts. I have to do it again over here. I want that corner. That, each one has to be different. I can go change those in a minute. This one I have to change where it is. And so I can edit it, edit where it's going to be. I think I've got them all. No, this one's in the right place, wrong place too. And so that's kind of cool. I got my 4 pieces up there. And now check this out. Now I'm going to put some back on again. Here. And I'll put it so that it ends up that 8 foot high. And I'll put one here. Now, what's really fun is I have the choice now of how to make these ends. I can miter the 2 ends. And it's drawing these, it's making these parts as I go, by the way. So I might as well miter these 2 also. But maybe over here, I get a little wonky and I go trim extend. I'll go to that point with that one and that one. And now, of course, I can put my top piece on. So now let me put this one on, and now I will do rectangular. And I'll put 3 by 1 by 1/8, just for fun. And you can see what I'm making is the pergola. And I could make this out of different stuff now. Now, if I wanted to, I could put the other ones in and everything, but you can see I've got this cool structure now.
Could you have done it in a 2D and then just had it automatically draw the 3D?
No, because it makes every single one of these parts.
Okay.
So you have to use its generator to do it. And as an example, if I were to make the drawing view now, there's my little drawing view, but I can put in base pieces now to show what all the cut lengths are. There they all are. Right? And so I need 2 of these. 1, 2, 3, 4, 5, 6, 7, 8 of these, but they're not all the same. Oops, wrong way. And so that's showing the shape. And then when I project it, I get all my cut lengths. Isn't that cool? And so I know that I've got two of those, which were these two things. And I can do this all with a bubble diagram and bill of materials and everything. But I love this because I can really do cool stuff with it. And I think I can break this thing too. Isn't that awesome? But I think that when I dimension it, it gives me my real length, except I didn't get to the right spot.
So that'd be useful for doing, like documentation on putting parts together.
Yep. Oh, look at that. See, I don't even need to, it knows what that was. So I don't have to take up my whole drawing. And of course, I can put my angle on there. And if I need to, I can make a reference here. But you know what they're going to do, right? The important thing is this 96. So they'll cut with the saw going through the 96. Isn't that the coolest thing, though? This I don't believe is possible in AutoCAD. I don't think that capability is in there. The other thing I can do is I can auto balloon this one. I can select all those parts. I can say put right there. Now I just have to see which ones are which. Yep, that's good. So now, if I had been smart and made these ones all the same, right, I could have just said make 8 times this and 2 times that. Would have been a better design. Isn't that cool though? Now, I think that I can do a frame analysis on this. Let's do a frame analysis. And it's going to be the same type of thing. Doesn't like something in there. I'm going to fix that one, that one, that one. Fix. I guess I have to click the fix thing each time. So those are now cemented into place. And I can put loads on these things. So I'll put a continuous load on that member of 50 pounds per inch is a lot. I'll put 10 pounds per inch. And I'll put the same thing on this one. And there goes the simulation again. So this one says it's going to go almost 3/16 of an inch. So that's maybe good, maybe not very good, right? Maybe I need a couple more stringers to even out that load. Because this isn't going too much. Maybe I want some ties along here. But it lets me really figure out what's going on. So those are my displacements.
Can you simulate wind shear?
Yes,
Or
yes you can, but you have to know the loads that are developed in wind shear.
okay.
Now, Fusion has a wind tunnel plugin that you could stick this in a wind tunnel in Fusion. But in Ventor, you sort of have to know what those loads are going to look like due to the wind. So, at least what we've got, right? We don't have everything that was ever made from it. But it's pretty cool. Just very quickly and easily you have these capabilities. So I think it's neat to see what some of these other programs do. This is a good tool. I could make these out of wood and then have load calculations and all that kind of stuff to give to the city, to do all sorts of stuff, although you can just get them out of a book. But, my teaching style is that I want you to see as many different things as you can, even if you'll never use them. They're out there, they exist. They might be of interest or they might not. But now you've seen one more cool thing, because this is an introduction to computer-aided design and drafting. And this is part of computer-aided design and drafting. So there we go. Any other questions on that? I wish I had done the generative design. But I got a lot of stuff done for you on this. There's a bunch. So here's where you put the corner seams in, right? And then I think somewhere in the weld one, you get to actually combine.
Okay.
So as an example, if I wanted to, I could do, so here would be one way to do it. There's an extend face in here somewhere. No, it won't do that. But there is a way to actually put that right up to it and then do the union command. Is another way to do it. That's for surfaces. I'll have to play around with that. Thicken. Okay, so it allowed that. So let's see what happens if I do the combine. Nah, so it won't let me do a combine there. I'd have to actually add a little piece in there and do a combine. What a pain. Good grief. I hate Bing. So, but you can see what a weird thing that does there. Cool. Now you got me thinking though. I'm going to just try put that into a weldment. I haven't done this much before. So that's where you do it somehow, but I don't know how. I guess it could, it's not really a fillet.
Yeah, why wouldn't it be?
Well, a fillet usually has a corner of some sort, and this doesn't have a corner, it's a gap.
Oh, I see. I visually I was looking at it as a corner.
Here it is. Full face weld, full face weld. There it is. So I did something down here. But it did something weird. So that's where you do it, but I don't know how. Because it did something really it put it on the full oh, I see what it did.
Yeah, it went down the back side of that.
Because I said full face. So it did. So I'm doing something wrong there, but that's where it's going to happen. The groove weld. It's going to be face 1 to face 2. There, did it just do it? There we go. That just welded that edge. Now we'll return, and now you can do your stress analysis. Okay, you just taught me something. That's how you would weld it. It's there. Isn't that neat?
Yeah, that's really cool.
And I could have made it a weld symbol and all that other kind of stuff. So, if we were to run it now, of course, it wouldn't kind of move at all, right? Let's just see what happens if I do it again. Because I don't know what I did there. That one didn't do it.
No, you need full face weld on sides 1 and 2.
I don't think so. I think,
Because that's what you did on the other one, is you selected the end pieces as the face.
no, that full face put the weld all along the whole thing. Oh, I see. This one, for some reason, has a different corner. This one is a fillet. And I don't know what I'm doing here. There it goes. But it's not liking it on this one. Probably too much of a gap. But I don't know why this one.
I was pretty sure on the other one you had checkmarked face, but then selected the faces as the end pieces of the sheet metal, where the first time you ran it, it had selected the whole back face.
Yeah, but this, see how those are in line? These ones aren't.
Oh, interesting. Huh.
I don't know why. I don't know why that is. So I could probably extend that face and then be able to do it. I don't know where that is that I do that. I probably have to go back to the original part. But that's something I didn't notice before. Isn't that odd?
Yeah, I don't think it was that way when you did it, the initial drawing.
Really? Okay. Maybe it pulled in then, huh? Yeah, it's just telling me okay. See how it does that weird thing all along it? So that can't be right.
Huh.
Well, that's okay. We'll figure that out at some point. At least we got a little start on it that we can start playing with. But that's how you put a weld in. I haven't done that before. That's kind of cool. Okay, then that's where we're at. Tomorrow is our last day of class, and what I'll do is I'll just ask. I'm going to be asking people to share their portfolios. Actually, I'll do it, and just I love to show good work. So I'm just going to be picking and choosing and showing what people have drawn and how they've presented it. I just think that that's fun. Okay, so there we go. Good stuff. I'll stop sharing and I'll stop recording.